Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ in front of you. So you can see the question. This is phenylacetic acid reacts with this two step and produces one major product, and you have to say what is the major product. Here four options are provided. One of them is the right answer. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. Don't hesitate whether your answer will be right or wrong, because self-evaluation is essential for improvement, and that's why you must try. I believe you have tried by yourself, so it's my turn to give you the right answer. By the way, this is the reference of this problem. Now, so you can see here the molecule is pretty simple, phenylacetic acid, and its reaction in two steps. In the first step, if you look at it, is trimethyl carbonyl chloride, or actually it's actually an student acid chloride. Okay, and we know the acid chlorides are significantly high electrophilic because of this minus I effect of this chlorine. Now, and second thing, we have studied that when carboxylic acid reacts with another different type of acid chloride, it produces mixed anhydride. And in this process, one molecule of HCl is produced. How? Chlorine from this acid chloride and hydrogen from this carboxylic acid produces, which is quenched by this 1.1 equivalent of triethylamine. So from these you can understand the medium is slightly basic because anhydrides are stable in that medium, and triethylamine is a non-nucleophilic base, so it will not react with anhydride. Fine. So based on this much understanding, let's start the discussion. So in the first step, it will produce this as anhydride, as I told. Fine. And if you want to know how this has happened, so let me give you a little description. So this is obviously double bond O, and this is OH, and this is student acid chloride. So this mechanism is nothing but acyl nucleophilic substitution. So actually attack happens from here, but for your better understanding I am showing here. So it attacks, it opens up, it come back, and Cl leaves, and from hydrogen here and Cl here, it produces HCl, which react with this triethylamine and produces triethyl ammonium chloride. Okay, and it gets separated out, and in this way this acid chloride, this mixed acid anhydride is produced, because the two sides of this acid anhydride is different. That's why mixed acid anhydride. Now in the next step, these treated with this hydroxylamine derivative in presence of one equivalent triethylamine. What happens here? Simply student, if you look at hydroxylamine, NH2OH, these hydroxylamine is significantly high nucleophilic, and the nucleophilicity is more in the nitrogen side. Why? Because the two adjacent lone pair repulsion makes this compound more reactive, more nucleophilic, and this is also called alpha effect. So this is more nucleophilic, and if you look at this reagent here, one hydrogen is blocked by methyl here, and obviously oxygen part also one hydrogen is blocked. So only one hydrogen attached to nitrogen is left. So it can act as a nucleophile obviously here. So these nitrogen will act. Now here there is a little twist. You can see NH2HCl. Why? Because this is the hydroxylamine hydrochloride salt. So you can consider that this reagent is nothing but, this is MeO NHMe dot HCl, and this dot HCl is consumed by one equivalent triethylamine. Similar way this will be produced. So in this way it will produce this nucleophile, and it will attack. It will do the nucleophilic substitution, or more specifically if I say acyl nucleophilic substitution. Now question is that since it is a mixed acid anhydride, so two center possible, number 1 and here number 2. Now nucleophilic attack will happen on center number 1. Why? Because if you look at the substituent part here, tertiary butyl group, it is too much bulky student. Too much bulky, and nucleophilic attack is governed by a concept named as Burgi-Dunich trajectory, and this bulkiness hampers the nucleophilic attack. By the way, I've already discussed a dedicated video on Burgi-Dunich trajectory. You may visit for better understanding. I shall provide the link in the description box. And compared to that, the bulkiness is less in case of this carbonyl, because the adjacent part is benzyl. So this nucleophilic attack will happen on this carbon. It will open up, come back, and it will leave. So in this way it will produce, obviously this is a mistake, in this way it will produce this one. Okay, so this derivative. Now this is actually it is not this way, student. It is actually a hydrochloride salt of, sorry, it is this cation, along with that this tertiary butyl. So I can say CH3 COO minus anion. Okay, so this NH and this is the salt, and when you treat this with additional one equivalent of triethylamine, it will instantly convert this Wenrep amide. Okay, and this Wenrep amide is a very interesting compound for synthesis of ketone and aldehyde by the treatment of organolithium or organomagnesium. And if you want to get aldehyde, you have to use lithium aluminum hydride as a nucleophile. Okay, so that's a different issue. What is the role of triethylamine and stoichiometry? I have already explained that in first case one equivalent, because one equivalent HCl is produced during this anhydride formation. Second case, the starting reagent is hydrochloride salt, so one equivalent will be there to quench the hydrochloride. Second, after the reaction there will be proton attached to nitrogen, means it's a salt. So in order to quench that, one equivalent additional triethylamine is needed, and triethylamine is specific proton scavenger or base. It can't act as nucleophile because of its bulkiness. So in short, what you have learned today, then that the key steps are first mixed anhydride formation here, and the second step is Wenrep amide preparation. Now, so what is the answer? Answer is obviously here the option, this is this option D. Okay, now this is the, now if the question appear on your exam less than 30 seconds, how can you solve? For that purpose, first you need to understand what type of reaction is given in the first step. It is simple, anhydride formation, mixed anhydride formation, and second step nucleophile is given. So based on this understanding, you can understand that okay, how tertiary butyl group can be there at 0 degree centigrade, so decarbonylation not possible, such that tertiary butyl cation not possible. So that part is not possible. Tertiary butyl cation generation is not possible here. So option A gone. Second thing, I have taken a carboxylic acid. Here it became, this part is reduced. What reducing agent I have given? Not that much in a reducing agent. So this is not possible. Hydrazine can act, but it's not that much strong reducing. So not possible. Third step, okay, this is actually an amide, is true, but here migration of this group happened. How? It's not possible. There is no driving force, an illogical option. So only option D is left. So by selecting proper choice also you can come up to the right answer. But I always suggest student, make your preparation as best as possible. So in conclusion, what you have learned today, that nucleophilic attack on carbonyl group is influenced by both steric and electronic factor, and this anhydride is a kind of carbonyl, and that's why this could be governed by the principle Bourget-Dunich trajectory. Second thing, bulky carbonyl is relatively bad electrophilic because of this bulkiness, like this tertiary butyl carboxylic acid, means tertiary butyl side even when the amide formation, amide formation. Now third point is that acid chlorides are very reactive electrophile, and it results in anhydride formation, both symmetrical and mixed anhydride with other carboxylic acid. Now in this case, hydroxylamine is better nucleophile due to alpha effect, that is the adjacent lone pair repulsion, and here the nitrogen center is more nucleophilic over the oxygen due to the less electronegativity of this nitrogen atom. And actually it's able to convert the ester into amide because of this enhanced nucleophilicity, means enhanced reactivity. And the final point is this Wenrep amide is a very good intermediate for ketone preparation using organolithium or organomagnesium reagent, means Grignard reagent at low temperature, because the first adduct could be isolated due to the chelation from the oxygen atom of hydroxylamine. Second thing, if you want aldehyde, then instead of the you can change the reagent into any hydride reagent like lithium aluminum hydride. So in this way, you from ester or amide you can directly produce ketone or aldehyde, but obviously low temperature is essential here. So this is the end of this question. I believe this video will be useful. I thank you everyone for watching this video, and if you really consider the content of my channel is worthy, then please help this channel to grow. So stay happy, stay blessed. See you in my next video. Take care. Bye bye.